Hey guys, welcome to our final chapter of the pre-algebra program. We are beginning chapter 9 today, section 1, entitled Squares and Square Roots. And first off, I just want to say I'm sorry that I'm giving you brand new material on Monday. I feel like as a rule, I love to keep the new material starting on Tuesdays, but we've had a lot of weeks of review plus a spring break in there for most of us, and so we just have to hit the ground running. We are 4 weeks away from finishing this program, so I promise you this last chapter is not very difficult. You might have had exposure to it already, so this final chapter is not that difficult. I try to save less challenging concepts for the end of the year when everyone has worked really hard and the weather is starting to change, and we're getting all antsy here as school is getting close to wrapping up. So hopefully you guys will hang in there. We're going to do 3 quick sections this week. I did give you Friday off for Good Friday. But other than that, we're just going to do some computations and it's not going to be bad at all. Okay, so today I want to define 2 terms for you. The first is called a perfect square. And a perfect square is a number made by multiplying an integer times itself. So you can take a look at my chart here, and I would encourage you to pause the video and go ahead and copy this chart down. Just to help you get familiar with what these numbers look like. But essentially what we're saying is these numbers here in red are what we call perfect squares. They are the numbers that are formed when you take an integer and times it by itself. It has to be by itself. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, and so on and so forth. Okay, so those are perfect squares. Then the converse of that we find by doing something called taking the square root. So if we wanted to take the square root of 9, what we'd have to do is ask ourselves, okay, what number times itself equals 9? Well, of course, it's 3, right? And you can see that on our chart here. So the square root of 9 is 3. 3 would be the answer that we're looking for here. So the square root is an operation that allows us to find what that integer is that multiplies itself to give me the perfect square. Okay, and then there are 2 rules in dealing with square roots that we need to talk about. And then I'm just going to crank out a few examples for you. These videos hopefully will be short and sweet this week, so you won't have to feel like they're too taxing. Okay, so the first rule in dealing with square roots is that you can take the square root. And I'm going to use that symbol just so that you begin to familiarize yourself with the symbol and the term. So you can take the square root of a number if it is the product of the same integer. I'm going to explain these 2 rules in a minute, so if that sounds a little confusing, don't worry about it. I'm going to tell you what I mean in just a second. The second rule is that you can take the square root only if the number under the square root is positive. Just so you know, sometimes people see this sign and they call it a radical, which I almost just said and I caught myself. And that is a more generic term that we'll use later on. But for our purposes right now, I'm going to try to just keep using the same term of square root because that's what it means for us right now. So So the two rules, you can take the square root of a number if it is the product of the same integer, and then you can take the square root only if the number under the square root is positive. And this is the key here, and I'm going to show you why that is in just a couple of minutes as we work through some examples. So, all right, let's jump in and I can show you what I mean here. These are really not bad at all. All right, so if I wanted to take the square root of 36, I would ask myself, is there a number times itself that equals 36? And the answer is yes. Now, of course, 36 has other factors. For example, 3 times 12. But I don't want any of the other factors. I only want the one where the number is multiplied by itself. Okay, that's the space that we're going to be in this section. So, of course, the number that multiplies by itself to get 36 is 6. So the square root of 36 is 6. That's the answer they're looking for. They're not looking for 6 times 6. They just want the number. Okay. And then what happens if we wanted to take the square root of 15? Okay, so this is going to be in reference to the first rule that I just gave you. Now we're looking for a number times itself that equals 15. But the only factors of 15 are 15 and 1 and 15 and 3. There are no numbers such that when multiplied by itself give you 15. So we cannot take the square root of this number. So it's impossible. And I think that the directions just ask you, like, take the square root if possible. So if you get a situation like this, you can just simply write cannot take the square root or not possible as your answer. Okay, remember we're looking for an integer times itself. Okay, next one. What if I wanted the square root of negative 81? All right, now this is the second rule that I just gave you. The number underneath the radical must be positive. In this case, notice this negative underneath here. So this is not possible. We cannot have a negative underneath the square root sign. We can't do it. But we can put it outside the square root if we wanted to. So notice the difference between this problem and this problem. In the first problem, the negative is underneath the square root. And in the second problem, the negative is outside the square root. All right, so in the second case, we can solve this and then multiply by that negative at the end. So I can get a number times itself to equal 81. In this case, it's 9. But now I'm going to multiply by this negative, and so my answer is actually going to be negative 9. Okay, let's do another example like that so you see the difference. If I wanted to take the square root of negative 49 versus the negative square root of 49, this one is not possible because there's a negative underneath the square root. But in this case, the negative is outside the square root, and therefore we can multiply it at the end. So what number times itself gives us 49? Certainly, it's just 7. And so then we would multiply the negative there at the end and make it negative 7. All right, 2 more quick examples for you. What if I wanted to take the square root of 110? Well, you're going to work it down and you're going to try to find a factor times itself, but you're not going to be able to get there. So this answer is not possible because no number times itself equals 110. However, if we wanted the square root of 121, we could take the square root of that because the answer is simply 11. Okay, that's it for this section. Basically, what you're looking for then are just those two rules. You want to make sure that that number that you're looking for is the number times itself in order to take the square root. And then, of course, the negative, if you see one has to be on the outside of the square root, it cannot be underneath it. All right, y'all, finish up these notes and read through the examples in the book and begin your assignment.